Polynomials. In this series of chapter polynomials, till now we have seen about the types of polynomials, that is linear, quadratic, cubic, and how the types are dependent on the degrees of the polynomial. Then we have seen about the zeros of polynomial, how the zeros are related to the types of polynomial, whether it is a linear, quadratic, cubic and all. Then we have seen about how to find the zeros of a polynomial, and also how to show that a particular value is a zero or not. Then we have seen about the relation between the zeros and the coefficients of the quadratic polynomial, like the sum of the zeros is minus b by a, product of the zeros is c by a, where b is nothing but coefficient of x and a is nothing but coefficient of x square and c is nothing but the constant term. So this way we have seen what is the relationship between the zeros and the coefficient. And in the last part we have seen that if we are given that alpha and beta are the zeros of a given polynomial, then how to frame another quadratic polynomial for the given certain conditions. In today's part, this is the last part of the series called polynomials. In this part we are going to discuss very important question based on, and which is very important with respect to the board exam. Okay, so let's first have the question. So here is the question. The question says, find the zeros of the quadratic polynomial 5x square plus 8x minus 4 and verify the relationship between the zeros and the coefficients of the polynomial. Now first we have to find the zeros. This type of question we are seeing for the first time, where we are trying to find the zeros and then we have to verify the relationship between. This is very sure question for 3 marks which will definitely come, and that's why we are taking this question here. Okay, so let's start with the solution. First we will consider the polynomial. Let p of x equals to 5x square plus 8x minus 4. Now when we are trying to find the zeros, so first we need to factorize the given polynomial. Now we have learned many methods of factorizing. Here we are going to use splitting the middle term. So how to split the middle term? We know that 5 fours are 20. So we have to split 8 in the form of factors such that which on multiplication will give 20 and minus 20, to be specific, minus 20. So the coefficient of x square is 5 and constant is minus 4, which gives out minus 20. Now we have to split 8 in the way so that on multiplication those numbers will give minus 20. So we have minus 20 factors, 2 into 10 minus 10 and minus 2 into 10. Okay, now you have to check 2 minus 10 will give us minus 8, but here you want plus 8, and minus 2 plus 10 will give us plus 8. So we will consider this one. Okay, so what we will get here? 5x square plus 10x minus 2x minus 4. Now in the first two term we have to check what we can take out common. So we can see here that in the first two term 5 is common and x is common, so we will take out 5x. On taking out 5x common, we are left with x and 2 here, x plus 2. Then in the second last two terms we can see minus 2 is common, so again we will be left with x plus 2. Now how to check whether this is going on correctly? If this bracket, these two brackets are same, then we can check ourselves that yes, our factorization is going on correctly. Okay, then further we will take out x plus 2 common and we will be left with 5x minus 2. Is it very clear? So these are the two factors of the given polynomial 5x square plus 8x minus 4. Now on equating with 0, we will get the two zeros, like if x plus 2 is 0, so it implies x equals to minus 2, and if 5x minus 2 is 0, so we will get x equals to 2 by 5. Is it very clear? 2 by 5. So we will say the two zeros are minus 2 and 2 by 5. So what we will say? Hence zeros of the given quadratic polynomial are minus 2 and 2 by 5. Is it very clear? So we got the two zeros, minus 2 and 2 by 5, and why it will have only two zeros? Because it is quadratic polynomial. Okay, so quadratic degree 2 means two zeros. Okay, now we will check how to verify the relationship. Okay, so just we'll check for that. Now we got alpha as minus 2 and beta as 2 by 5. Okay, and we have to check the verify the relationship. Okay, so we know what is the relationship. We know that sum of the zeros alpha plus beta should be minus b upon a, and alpha into beta should be c upon a. For that we must know first what is a, what is b, and what is c. Our polynomial was 5x square plus 8x minus 4, which implies a is 5, b is 8, and c is minus 4. For verification, one very important thing, first we will do the LHS and then we will check for the RHS. So LHS is alpha plus beta is equals to minus 2 plus 2 by 5. 5 2s are 10, minus 10 plus 2 minus 8 by 5, and RHS will be minus b by a. What is our b? 8, and what is our a? 5. So it will be minus 8 by 5. What we can say from this thing, that LHS is equals to RHS. LHS equals to RHS means verified. Is it very clear? Same way for product of zeros, LHS gives out alpha into beta, that is, what is alpha? Alpha is minus 2 into what is beta? Beta is 2 by 5. 2 into minus 2 will get minus 4 by 5. And what will be the RHS? RHS will be C upon A. C is minus 4 and A is 5. Okay, so LHS equals to RHS. So we will write LHS equals to RHS, and then we will write hence verified. Is it very clear? Hence verified. So this is the way where we first find the zeros and then we verify the relationship between the zeros and the coefficient. I told you that this question is very important, and it very surely it comes for 3 to 4 marks. Okay, so hope the concept is clear, hope the chapter is clear, and all the concepts related to this chapter called polynomials are clear. So with this we'll stop here. Take good care.